Welcome to our live training session. We're going to be taking a look at how to calibrate and tune a 2017 Mustang GT using HP Tuner software. Let's jump into some details about our vehicle. We're going to find this has a bone stock engine and 6R80 automatic transmission. And we've added a bunch of aftermarket mods. We have long tube headers, high flow catback exhaust. In addition to this, we have a GT350 intake manifold, throttle body, Ford Racing 47-pound injectors, DW400 in-tank fuel pump, and the big modification here is an ESS G3 supercharger kit. Now we're going to learn how to calibrate and tune this safely on 93 octane. We're pulled up to about 7 to 8 psi of boost, so I'm anticipating having some great results on this kit with our demo vehicle. Without further wait, let's jump into our live training session so we can get started. Welcome to our live training session. Now we just went over all the details of our vehicle. Let's jump into our VCM editor software to begin creating our base map to get our engine fired up and running so we can calibrate and tune our ESS supercharger kit. Now if we take a look here on my laptop screen, I have the VCM editor software already open. Now I have a file loaded in here already that I've read out of our vehicle. Now this vehicle is the same demo vehicle that we did our previous live training with. That was basic bolt-on mods. We went through, we calibrated and tuned everything on petrol and on flex fuel. This is now going to be just running petrol, but I've read the file out of the vehicle. This is going to be the starting point that we're going to be moving forward with. Now we're going to be applying template applicator files and data to the calibration file we have here existing, and it's essentially, I'm going to be treating this like I'm starting off with a bone stock file and then edit and modifying everything from that point. So we're going to go through, apply our template files, then we're going to go through and take a look at the calibration file, making sure in each tab, in each section, everything is in order to get our engine to fire up and run. Sometimes the template files may turn something on or off unintentionally. We're going to be just going through everything, making sure everything's 100% in order to start off our engine and begin our live training with. Let's jump in here. Now that we have our file here as red file, we're going to start off and use our very first template applicator file, which is going to be building our base map prep. This is going to be just applying general changes that we typically want to make to a Gen 2 Coyote setup. Let's go in here and apply that first, and then we're just going to go through kind of the order of the changes that we want to make with our template files. There's a lot of them, there's a lot of data that needs to be updated for this. Let's go here to edit. Let's go here to template applicator. Let's go here to file open tune template, and we're going to move into our Gen 2 training course folder. Now I have that saved here under a subfolder here, training courses, Gen 2 Coyote. Let's move in here, jump into our template applicator folder, and we're going to move to base file prep subfolder into the auto trans, and we're going to select what rev limiter that we want to apply for our setup here. I'm actually going to choose the 7400 RPM rev limiter for two reasons. First, I have not upgraded the oil pump gears on my engine. Anytime you install a supercharger, you have more of a risk of breaking the oil pump gears. It can even happen naturally aspirated, but especially now that we have an extra pulley set up here and we're putting more tension on the crank snout, the oil pump gears can break. It's more prevalent with Whipple and Roush kits than it is with the Century style kits, so the Paxton, the Vortec, the ESS kit, but just to be safe, I'm going to command a lower rev limiter. The other thing that I have to factor in here is that I only have 47-pound Ford Racing injectors. I'm likely to top out on the injector flow and hitting at very high duty cycles if I start to rev it out much higher than stock. So 7,400 RPM is going to be my limit. We'll have to feel this out as we're calibrating and tuning our engine and keeping track and keeping an eye on the actual injector duty cycle. I've done plenty of other S550s with the 47-pound injectors on 6 to 8 PSI range on supercharger setups, and we're usually going to be maxing it out about that boost range, about 6 to 8 PSI. So we need to be careful with this. We do have the upgraded fuel pump, but the injectors are likely to be a flow limitation. So I don't want to rev it higher. The higher you rev it, the more duty cycle, the more fuel flow you have to command, and we don't want to go static or 100% duty cycle on the injector. So we're going to select 7,400 RPM. This is going to apply all the general changes to make sure we're able to actually rev our engine out to 7,400 plus any other minor or general changes that we typically make. We can see all of those changes right here. If we scroll down, we can see what that all looks like. So we'll go through and just verify everything is in order when we check our file after all the template files have been applied. Let's go here to apply changes, and we can see here everything's been applied except these switches. I'm not super worried about this. We actually have high flow CAT's installed, so I want to keep the rear O2 sensors activated. We can see this is related to rear O2 sensors, so let's go ahead and close that out. Now I'm going to go back in here, edit, let's go here to template applicator, file open, open tune template. Now let's look at the other options that we have here in our template applicator folder. So if we go down here, we have a force induction new folder. Now, if you've downloaded the course packet already, so let's say you've watched a previous live training tutorial, maybe that was a year or two ago, I have updated new template files specifically here under force induction new. There's all kinds of new data that we can bring into our file for a force induction setup, which is how we're going to be building things in this tutorial, including a custom VCT schedule that I've used on many different S550 Mustangs with supercharger, turbocharged setups. It simplifies the map points greatly. So we'll be looking at that and applying that here in just a little bit. But let's go and actually apply our injector data. We have 47-pound injectors in this. We're going to go to our Ford Racing injector data, and we're going to grab 47-pound option here, and we're going to go ahead and apply it. Now, the one thing I'm going to do is double check our offset versus voltage right here. We want to make sure that as the template file is applying the data, it hasn't skewed our offset table values. This is a common problem for whatever reason with the template applicator files. It seems to always happen with the injector dynamics data. If you've used my data and you've applied it and you're having problems firing off the engine, maybe it fires off and it dies because it's too lean, it's likely because the offset versus voltage data is skewed when it was imported into the file. So we're going to go apply this and immediately check it in our calibration file to make sure that there's no problems or errors. Let's do that right quick here. Let's go to apply. We can see everything's applied successfully. Again, we're going to immediately jump in here and do a spot check on that offset data. Let's go here to fuel under general, injector control. We move down here under offset, offset versus voltage. We can see here that the data looks okay. What I've noticed when the data is applied incorrectly for whatever reason with the template file is that it shifts everything over 2 to 3 decimal points. So instead of, for example here, 1.483 milliseconds, it'll apply it as 0.001483 milliseconds, which is obviously way too small, which is why you try to fire it off and the engine runs extremely lean at idle, because you absolutely have to have the offset correct. So this looks okay. We want to do a spot check on that data here. So let's close that out. Let's move back up in here, edit, template applicator, and let's go in here and apply some additional changes. So let's go back into our folder and take a look at what other changes that we can make here. One thing we definitely want to account for, the intake manifold and throttle body. I've changed the intake manifold out to the GT350 as well as the GT350 throttle body on this. I've also applied the intake manifold control runner lockouts. So we've locked them out. We have open runners. We're not going to be having that flapper valve doing anything anymore, which changes our VCT scheduling, and we have to go in and update our engine control module here so it recognizes that. We're going to do that in a little bit, but let's go and apply intake manifold and throttle body data changes. Let's go here to intake manifold, and here we can see GT350. Now what this is going to do is just change the manifold volume to represent the correct manifold volume for the GT350 intake manifold. I'm going to go here to apply changes. Simple enough, that applies it real quick. Let's now apply our throttle body data. It's super important that we get this populated correctly, or it's going to lead to a lot of torque control problems and torque errors. Let's go to edit. Let's go here to template applicator, file open, open tune template, and let's move in here, throttle body data. Now we have a whole bunch of different options to choose from. We're going to go ahead and select GT350, and we are going to go ahead and apply our changes. Everything here looks like it applies except the shuffle disable RPM. That's not currently found in the tune. It is there, it's just the HP tuners didn't define it in my particular operating system for whatever reason. Not a big deal. The anti-shuffle should already be disabled within automatic. I think it mostly applies to manual if I'm correct. It's been a minute since I looked at it, but we don't need to worry about this. We can skip over that scaler, not a big deal. Now, let's jump back into our template applicator and let's take a look at some more information. Template applicator, file open, open tune template, and I'm going to go in here. Let's take a look. There's a fuel pump, and I've added this in. This is something new. We're going to be applying our DW400C in a returnless setup, the fuel pump changes that we need to make. which is specifically going to be bumping up our inferred pressures, because once you install in a returnless system a DW400C pump, it bumps up your base pressure about 7 to 8 psi. So if we go ahead and select this, we're going to find that both our inferred pressures are raised up with this template file about 7 to 8 psi, which will be better representing the base pressure, which is a lookup into your injector data, making sure that your fueling is more accurate. Okay, we're going to go to apply changes, go ahead and apply that. We can see those applied. Now let's take a step back here, make sure we didn't miss anything before we go to the force induction folder, because that has a lot of changes.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.